So I am actually, this talk is going to be a little bit different from the others. Also, I'm going to move, so you're going to have to follow me. I'm actually not here today to talk to you about code. I want to talk to you about ideas. And the ideas are a review of where we have been as a PHP community and how our processes of development have evolved, and also, more importantly, where we're headed. So this is a little bit about me. I worked on a framework called Cake PHP for about 5 years, about a year and a half of which I was the lead developer. And then I spun off another project called Li3, also known as Lithium. And we'll talk about that in a little bit. I also work on another project team called Angular UI, which is a set of tools and libraries for AngularJS. How many people use Angular here, just out of curiosity? Okay. Oh, wow, quite a few of you. That's great. And I work as an architect at a consulting firm called Ratify. And what follows is a whole bunch of my opinions. I might be wrong, but we'll talk about it. And if you think about what I have to say and decide you want to ask me questions or tell me I'm wrong some later day, you can contact me via email or Twitter. Like I said, I work with a consulting firm called Ratify. We do consulting, training, and software development. So I want to open with 2 quotes. The first one is from a physicist called Niels Bohr. It's difficult to make predictions, especially about the future. I'm going to try to anyway. Again, I'm going to try and make this a discussion, so we'll save plenty of time for questions at the end, and we'll talk. Also, this quote by a guy named Alexis de Tocqueville, who wrote about government systems in America and kind of the culture and the mentality of Americans, how we don't think much about the past or the future. We're just always in the present, and which is one of the reasons why we can't have nice things. But if you think about it, programming is also a little bit like that, because we're constantly inundated with this stream of new tools and new technologies and techniques and different things, but fundamentally the way that we write software and the way that we think about writing software hasn't really changed. We've still been writing in text editors, which we've been doing for the past 40 years, and even writing code in text editors goes back to even older ideas of punch cards and teletype. So it's important to think about these things, but why study the past? What can we learn from the fact that we've been coding in text editors for 40 years? The problem is, if you don't study the past, first of all, you can't see where you're going. You have no idea. You can't follow the trajectory of where you've been and where you're going. But more importantly, I think studying the past gives us a context to think about the present. Like normally, we don't think about the fact that we code in text editors. We don't think about MVC as maybe whether it's a good idea or a bad idea. We don't think about design patterns. We just kind of accept them as reality and don't think about them critically. But examining the present in light of the past gives us context. It allows us to kind of step away and separate ourselves from the present so that we can actually reason about it and figure out if what we're doing is okay or if what we're doing needs to change. So a little bit of history. Starting from about 2000 to 2004, the state of PHP development was not so good. We had this idea of separation of concerns with templating systems like Smarty. We had component libraries like Pear. And we even had some very rudimentary frameworks like Whacked and Fusebox, and there were some other ones that were around at the time. But they were sort of rudimentary and simplistic compared to what we have now. Also, you didn't have a lot of, there weren't a lot of ideas about best practices the way that we have them today. So then in 2005, we have Cake PHP and some other ones. Now, I'm talking about Cake because, it's what I know. Obviously, Symfony and CodeIgniter and Yi and all of those other ones were around, and they were great. But again, this is my opinion. I'm speaking from my experience. To me, the key innovation of Cake, which of course we stole from Rails, was the idea that you have these unifying conventions that sort of bring together all levels of the stack. You have this single cohesive package and a single way of writing applications. And that was totally new. No one had ever, at least in the context of PHP, no one was really doing that prior. Everyone, kind of had their own library of classes, own style, own way of doing things. So this was really like a new key thing. So then, when we move into like 2009 to 2012, we get this whole second generation of frameworks. And somebody asked me to talk a little bit about how I got from Cake PHP to Li3. It was kind of by accident. Around the time, I think it was like mid-2008, so like summer 2008, PHP 5.3 had just gone into beta. And I thought PHP 5.3 was pretty cool, so I was downloading the snapshots every night and compiling it. And I just thought it was amazing, like the fact that you could organize classes into namespaces and you could do functional programming with closures and anonymous functions. Like this just blew my mind, and we didn't have these nice things in PHP before. So it was really great, and what I wanted to do is see if I could try and solve the problems that we were solving in Cake with these new tools. So I wrote a few test scripts, then I wrote a few more test scripts, then I started organizing the test scripts into a directory structure, and suddenly there was a framework. I don't know what happened. And yeah, it was weird. So that happened, and then I took the work that I had done and brought it to the Cake PHP community, and I was like, hey guys, I think this is the direction we should go for Cake. What do you think? And everybody kind of freaked out, because they liked Cake the way it was, and that's okay. I decided that I wanted to try a new thing, so I went and did the new thing, and they kept doing their same thing, and it's all good. So, but there's room for that in the world. There's room for trying different things. So no big controversy, if that's what you were looking for. And the key innovation that Lithium brought to the PHP ecosystem was the filter system. How many people have used Li3 before, ever? Nobody. All right. Woo! So PHP implements this thing called a filter system. It's based on the concepts of aspect-oriented programming, where you have a method that's in a class, and you can actually wrap it with this thing called a filter. And a filter is just it's an anonymous function that is able to intercept the parameters of the function and also intercept the return value. So things like caching and logging and access control are all really, really, really easy to implement with this paradigm. Because you have, a class like, a model or a controller or something that has business logic attached to it, and it has methods, and you don't want to tightly couple it with, logging classes or any other classes. So the filter system gave you a way to hook those classes together without them knowing anything about each other. The other thing that was new at the time that Lithium came out, and this was back in late 2009, was the idea that the framework could scale up and down with the needs and complexity of the application. So it was a full stack framework, and you could use it as a full stack framework, all the MVC tiers. But you could also use it as a micro framework. You could use just the routing. And route to your own custom classes and not use any of the rest of the framework. So that was kind of a new thing in PHP also. The other framework that was released shortly thereafter, like maybe a year later, was Symfony 2. And by the time the Symfony 2 framework came out, most of what was considered Symfony 2 already existed in the form of Symfony components. So they took that same idea even further by designing components like standalone, they still have a lot of dependencies. But they designed the components first, and then the framework on top of it second, providing a stratification with clean boundaries. A short time later, we also had Composer and Packagist becoming popular. So for the first time, you have the same kind of redistributable components as you found in Pair. But the problem with Pair was the rules. It was a very high barrier to get a package into Pair, whereas Composer and Packagist gave you the same ease or an even greater ease of installing packages than Pair gave you. But it was also a completely open market for components. So anyone could submit a package, anyone could work on a package, and then the community could decide which packages are best and which packages are highest quality compared to Pair, where it was, gatekeepers. And then we had a bunch of JavaScript frameworks. So why am I talking about JavaScript frameworks in a PHP talk? Well, up until this point, we traditionally thought of PHP applications as MVC. You have your model that talks to a database, and you have your controller, and then you render some views in Twig or PHP templating or whatever. Well, around this time, JavaScript started eating the view layer, because you have all these applications that have very highly dynamic requirements for interactivity, no page reloads, single page applications, all of these things that were enabled by advancements in the browser, where PHP is becoming less and less of a good fit for designing things that render in the browser. Instead, PHP is becoming more a tool for designing APIs or services or middleware, and that's changing how, the tooling for PHP and how we focus our development. And then really recently, we've had a couple of key tools and key innovations that have really changed the landscape for PHP. One is Hack. Has anybody used Hack yet? All right, one guy, awesome. Two of you, great. So I think Hack is fantastic because it gives you the same rapid prototyping freedom that PHP does, where you just, you still have a compiler in the background, but you can just start typing in an editor and refresh and watch things change. But it gives you the performance of the HHVM, and it also gives you a type system. Now that type system is optional. You don't have to use it in every single place. But I mean, types, that's really a weird thing for PHP, which is such a dynamic language and such a dynamically typed language. Well, types, as we'll see a little bit later, actually help you really effectively reason about systems and about the flow of data within the system. So it eliminates some of the need for writing certain kinds of tests. It also eliminates a lot of very common problems. And again, it allows you to reason about the behavior of your system. Also, we have these React PHP, which is a collection of libraries for doing dynamic asynchronous I/O, non-blocking, streams-based. Just like in Node.js, we can now do all of this stuff in PHP. So that's kind of from where we were to where we're at. Let's take a look at some of the trends in the marketplace that are taking place and are going to inform where we're going to go with our development. So first of all, real-time. We've definitely established beyond a doubt that people, like customers, do not want things to be any slower. Like, that's definitely a clear thing. Now with dynamic applications, mobile applications and things like that, the expectation has been set that things will be dynamic, things will be real time, and the UI user interfaces will be very reactive and responsive. Mobile is another key one. Mobile usage on the internet is actually expected to surpass desktop usage, I think, within 2015. Many places in the world it already has surpassed it. Also, native apps for mobile and desktop. People are now using web technologies to design native apps across many different platforms. So we have to, from the same code base, we have to have many different deploy targets. Finally, more of pretty much everything. So more data, more traffic, better performance, more sophistication around the applications that we design. People are just going to continue to want more everything. So the requirements are just going to get harder and harder as reflective of that. So in order to take this list of things and figure out where we're going to go in the future, we kind of have to go back and back to the basics. In order to move forward, we have to ask a couple of key questions. The first one is, what makes PHP great? And the second one is thinking about how we do our jobs. So what's really great about PHP? It's, again, really easy. You just start typing in a text editor, bang away, hit refresh on the browser, and boom, you're done. There's no tedious setup, no complicated steps to deploy. Oh gosh, I better hurry up. Large community and talent pool, self-explanatory. A lot of good resources. The community's evolved in terms of best practices. How many people know phptherightway.com? All right, good deal. And we finally have a large proliferation of high-quality components and tools. But there are some things that we have to start rethinking. How many people have read Anthony Ferrara's Beyond series? Okay, a few of you. Everybody else, you have homework, because this is required reading for everyone. The key point that Anthony makes in this particular post is that you can take all, I think it's like 24 patterns that we typically deal with in PHP and boil them all down to one single responsibility, which is managing the flow of data within the application. And really, if you think about it, that's all the applications are, is you're dealing with a composition of data structures on the one side and a composition of user interfaces on the other side, and you're managing the data flow and computation between the two. And so, based on what the requirements that we've discussed, maybe PHP isn't so good for the UI side. Maybe PHP is really good for the data side. It's really good at talking to many different systems at the same time. It's really good at composing data from lots of different places. But there are maybe some better tools for rendering HTML and making HTML really dynamic, like Angular and Ember and that kind of thing. And in some applications, maybe PHP is only good for just managing the data, and some applications, most of the processing should be done on the front end. That's okay too. In some scenarios, you have a lot of enterprise things like Java and C++ backends, and PHP ends up being the middleware for that, and then it talks to the UI, which is something else. That's okay too. All of these scenarios are valid for PHP. The important thing is not to get too dogmatic about saying PHP must be used everywhere. It's really good at some things, but it doesn't have to be good at everything, and that's okay. So the other problem that we have is, as a programmer, you kind of have these two hats that you wear. You have an architect hat and an engineer hat. And those two disciplines are very tightly intertwined, and we don't have really good tools and ways of reasoning about them separately. which is why, even with all these frameworks and reusable components, we end up, does it ever feel like we're doing the same work over and over again for all these different applications? Like we end up writing a lot of the same code where it feels the same even if it's not reusable? I think that not being able to separate architecture from engineering has a lot to do with this. Because what do you do when you're designing an architecture? You know, you draw some boxes on a piece of paper or a whiteboard, and then you hop into an editor. And as soon as you hop into an editor, everything you wrote on the whiteboard is expired. It's invalid. It's no longer a reality. But if you actually had a single way of architecting systems that reflected the reality of the system, if you had a way for all of your tools, like from PHP to JavaScript to HTML, that could all talk to each other and understand each other, you could do a lot of really powerful things. For example, when you finish developing an application, you're ready to put it into production, you start making performance optimizations. What's one of the first performance optimizations? You always specify your field lists. So instead of doing select star, you select maybe the 3 fields that you need, and then suddenly your application's much faster. Now, if you actually had a way for the view to understand what the data is doing, and one system to talk between them, then you could write an algorithm or a solver that just figures out, okay, I'm only using these 3 fields in my view, generate the query accordingly. And you would only have to write that code once, and then never have to solve that problem ever again. Because that's an engineering problem, not a design problem. So there are 2 solutions to this. One, either our tools need to know more about each other, so the view needs to know more about what the model is doing, or vice versa, or we need real architecture tools that allow us to specify systems and then have all of the engineering be done in PHP or JavaScript or whatever's at the low level, and then one tool coordinates them all. So we don't really have that right now. What should we do in the meantime? Until we get there, here are a few sort of ways that inform how we can write code. One is to write things that just solve one problem. So where a lot of the complexity and difficulty in understanding comes from is that we have one thing, say a class or a library, that's trying to solve a whole bunch of problems. The best classes and the best libraries just solve one part of one problem. There's this great quote from Kent Beck where he talks about how designers need to focus on things together that should be together and separately that should be separate. And the language is really interesting here. He doesn't say coders or engineers or developers, he says software designers. And I think that's a really key thing because we don't spend enough time thinking about design. Again, we don't have the tools for it. Another thing is that when we're writing these simple modules that do one thing, they shouldn't make assumptions about how they're going to be used because composition is an architectural discipline, but computation, what our modules should be doing, is an engineering problem. And again, we have to learn to separate those. So don't make assumptions about how your code will be used. The next thing is this idea of clean boundaries. In order to have clean boundaries in between our systems so that they're composable easily, we need to take into consideration some way of being able to pull interfaces out. Sometimes this is a type system. Sometimes this is simple values like strings or integers. Sometimes this is value objects like request or response objects. Do you guys know Aura PHP? That's a really good example framework that all the components are separated libraries that communicate with each other with the value objects. So it's a very easy way of reasoning about these complex systems because you can just follow the trail of value objects from one component to another. In fact, this guy, Gary Bernhardt from Destroy All Software, gave a talk, incidentally, called Boundaries. And he explains how designing applications around a composition of stateful services, like things that talk to the database, things that talk to other forms of persistence, and value objects that are immutable and contain all of your business logic and no dependencies, is actually a very, very powerful way of bringing understanding back to complex systems, because all of these things are very, very easy to reason about. All of your business logic is encapsulated, it has no dependencies, it's easy to test, and you move it around the system just by passing these values to your different stateful components. So where do frameworks fit into all this? Well, in 2011, Bob Martin, aka Uncle Bob, gave a talk called Architecture: The Lost Years. And in it, he explained how the design of a system should reflect its intent. And an example he gave was like buildings and architectural drawings. So if we looked at the architectural drawing for this building, we'd probably be able to tell that it was a theater just by looking at the design. But what happens when you look at the top-level directory structure of Symfony or Cake PHP or Li3? You don't see the application, you see the framework. The framework has decided how things should be laid out, and that doesn't have any meaning for the specific domain of the application. So what that means is that I can't design your architecture. Matthew Weir-O'Finney, who works on Zend, can't design your architecture. Fabien Potencier, who works on Symfony, can't design your architecture. So again, if we go back to this idea that we have to separate things that are considered separately, well, what do frameworks do? Frameworks intertwine a set of libraries with a set of design conventions. And that doesn't make them inherently bad, but we have to think about this as the complexity of our application increases and often grows away from the framework's way of doing things. And honestly, if the tools are good, if Symfony components are good, if Zend framework components are good, then they should be good with any set of conventions, different ones from the one that they're designed. Likewise with conventions, if the conventions are good, then they should work with any set of tools. Now the good thing is that many frameworks already do this. Li3 started doing it from the beginning, where all of the individual components were packages that were meant to be used independently. Symfony, again, they designed with components first. Aura PHP uses value objects to transfer state from one component to another. Also, many frameworks are now able to be used as micro frameworks. So you just use one little part and write your own classes and compose your own libraries around the small kernel. So we're getting there, but we still have a little ways to go. So finally, where are we going from here? As I said, PHP is really, really good at composing together data from many, many different sources and different systems. It's good at talking to different systems. It's good at getting different pieces to work together. It's like glue. So as our requirements increase in terms of data storage, in terms of computation, we're going to need more tools and better tools to work with large data sets efficiently, things like non-blocking I/O, streams, and things like that. Again, we're getting there with libraries like React PHP, and just good design that allows you to funnel your data directly from one place to another as efficiently as possible. Finally, hypermedia. How many people actually know what hypermedia means? Nobody, that's okay. It's basically the most difficult constraint of REST. So most people think REST just means mapping HTTP methods to controllers. That's not really it. The idea of REST, and actually you had a slide from Yi that showed the link header. One of the main ideas of hypermedia is when you query a service for a resource, it gives you named links of other resources that you can get to from that resource that allows you to use your API or your service like a state machine. So instead of coding directly against URLs in browser front ends with Angular or in mobile applications, you can just code against the names of the links. So you can traverse from one to the other, and the system is discoverable. So we have some tools. The PHP League has a library called Fractal, which is really good. Finally, functional programming concepts, like we've already talked about a little bit with value objects, with composability, referential transparency, and controlling side effects. All of these ideas are really, really important and help us to reduce the level of complexity in our systems, because the systems we design are very complex, and complex systems are very easy to create and very hard to understand. That's it. Do I have time for the bonus talk or no? No bonus talk? That's okay.
Okay, thank you very much. We have 2 questions. Yeah.
Yeah, I did get started a little late, so.
Okay, you need 5 minutes for bonus, right?
Yeah, about. I'll go fast.
Okay, so here you go.
Yeah, several times you mentioned that PHP took many things from other languages, like Cake PHP took something from Rails, and like React PHP is exactly like Node.js. And over the several past years, my feeling is that PHP is catching up on other languages. And the question is, when will it stop? And in your opinion, will PHP itself and the PHP ecosystem of frameworks, etc., develop something unique that other languages and frameworks will copy?
That's a good question. I guess I don't really see it that way. I think PHP has a lot of good things going for it. It goes back and forth, right? Like, PHP has, well, I'd have to think about that. PHP is already pretty good. New ideas, and that's the great thing about things like Node, is Node was like a totally different way of doing things, because it was brand new, and they had the opportunity to do that. And then eventually PHP adopted those ideas in. I think the really, really important thing about PHP is that nothing will ever kill it. Because if something was going to kill PHP by now, it would have already happened. So, new things are going to come up, new technologies are going to be invented, and PHP is just going to eat them. So yeah, I think PHP will always survive. I don't think PHP has to create new things. Like, it's good the way it is, and we'll maybe experiment a little bit, but there's lots of opportunities to experiment, and new languages are great, and I'll actually talk about why in a second. But yeah, I'll think about that.
Hello, I have a question about big projects, because PHP is nowadays a system that allows to create really big projects, and some of them are very complexity. And the last days we have the service-oriented architecture that allows to decrease the level of complexity of systems. So what do you think about a service-oriented architecture on PHP? And maybe you see other ways to decrease the complexity of system on PHP. Thank you.
That's a great question. I think that ideas that work at a high level also work well at a low level. And that's true of the inverse as well. But I think the idea of microservices or service-oriented architecture is that, yeah, you just have little services doing little things, and they talk to each other. It's a great way of designing systems, because you can reason about the messages that are passed between the systems. That's just like system design at any other level, or value objects being passed between packages. So I think it makes perfect sense, and I think it's a great design decision.
Thank you. The last question, and then we are moving to bonus, right?
Okay.
I just want to continue his question.
Yeah.
Can I ask you to switch to the slide where you showed 4 benefits of PHP. 4. Yeah, that was before. Yeah, here. So simple, get moving quickly. JavaScript is not hard, and in this way, when you're saying PHP is becoming to be asynchronous, JavaScript is asynchronous as well. So in this case, I can say like JavaScript is more easier even than PHP. Quickly, JavaScript is quickly as I guess more quickly than PHP, right? Large community, talent pool. I don't know about the thing. JavaScript now in some charts, JavaScript is like the most popular language that people are start to learn more and more and just move into there.
Yeah.
When I'm interviewing people and I asking that, like, what's your direction? What do you want to do? They tell me about JavaScript. Like, JavaScript becomes to be more famous. That's so cool. I want to study more of that. I want to improve myself in JavaScript. Major, good research. Okay. A lot of documentation now is about JavaScript. A lot of things now on their IT research, programming websites, they're about JavaScript.
So it sounds like what you're saying is JavaScript is awesome and no one should bother learning.
No,
PHP.
I just want to say, like, in other languages, that's already done. So should we continue to, in the way if we want to leave PHP and this IT world, we have to recreate that in other way because PHP was created to generate HTML documents.
Yeah.
And now we need just to pass data between server and client. We don't need to generate any text. So PHP was created just for another goal.
Okay. I'm
Should
sorry.
we...
Calm down.
Oh, okay.
Ты перепутал конференцию. JavaScript Framework у нас будет весной. Я тут вижу, уже люди начинают там кулаки почесать. Давай, не, все поняли, да, JavaScript, ну, клевая штука, то есть по популярности он превосходит PHP. Давайте вернемся. Let's back to the bonus. Okay?
Okay.
Thank you.
So can I quickly answer that? Just to really quickly answer that, I think there are actually better tools than PHP to do templating, like I mentioned in the talk. Really the thing that PHP is good at is doing complex data transformations really, really simply. Actually, a lot of the array operations that are really simple in PHP, it's just like 2 function calls. JavaScript, it's like you have to have underscore or lodash, like this whole library. It's kind of a pain in the ass. So, and generally I think there's still a lot better, the tools for doing PHP on the server side are still a lot better, I think, than, you know, Node.js or whatever. And to your point about the community, JavaScript community is actually sort of really fragmented. Like you have, you know, people doing browser stuff and people doing Node.js stuff, and everybody kind of has their own style. And that's a little bit true of PHP also. But I think it's a little bit more cohesive. Hopefully that answers your question. All right, so really quickly, bonus talk. All right, so this is just a collection of a bunch of ideas that I think are stupid. It has nothing to do with anything else. So a few months ago, there's this blog post that was written that says programming is not math. This is a deeply, deeply dangerous idea, not because of what it says about programming or doesn't say about programming, but because of what it says about math. So prior to the invention of algebra, this is how people did math. You would have to have multiple paragraphs of text to equal one tiny little equation. And then algebra came along, and you were able to condense that idea and express it much more succinctly without losing any information. So naturally, the US education system is mostly terrible. So what we end up teaching is that the symbols, all the numbers and letters and everything, actually is math. We don't separate the language of math from the ideas of math. But one of the things that this tells us is that language is a user interface for ideas, for writing down ideas, communicating ideas to other people. So when you learn PHP, you think in PHP, you solve problems the PHP way, same with JavaScript. But we don't think about this idea very much that the way we express things matters. And we need to think about the problem at a higher level than the language to understand if the language that we're using or the design patterns that we're using or the framework that we're using is ideally suited for the problem that we're trying to solve. Also, programming absolutely is math, because once you separate mathematical ideas from mathematical language, what you find is that math itself, its essence, is actually just a way of describing relationships between values. Gee, that sounds really familiar, because so is programming. This is the other one. So this is a little bit controversial. Now, I want to clarify that I love the confidence that writing unit tests gives me, because when all my code is, when I do TDD and all my code is 100% coverage, I feel very confident that I can change the design without breaking things, right? So I really love that part, but I really hate the part where I have to actually write them all. Unit testing actually has some fairly serious problems that we don't really think about. For example, the tests that you write are only as smart as you are. And I found out after many, many years of designing systems and writing tests, I'm actually not that smart. So this is a problem. The tests only tell that your code does what you say. It doesn't actually tell that your code doesn't do what you don't say. And here's an example of what I mean. In math, in set theory, there's this concept called domains. It's basically this idea that you take a set of input, all possible inputs, and you take a function, and the domain is all possible outputs of that function, right? So it's a simple concept in set theory. You can write proofs against it. Proofs are like unit tests on crack, because they mean you actually have a mathematically provable way that a function only does exactly what you want and nothing else. So here's where set theory would have come in really, really handy about a year ago. Let's say the set is all possible data on the internet, and the function is OpenSSL. Somewhere in the domain was Heartbleed, and Heartbleed was in that domain for years. So unit tests can't solve this. This is a type of problem that unit tests can't actually solve, because the designers weren't thinking about, oh, this value is used here. Again, we don't have good ways of reasoning about systems. We write all this complex software, but we can't intuitively understand what it can or can't do. Unit tests are about writing specific cases for specific input and specific output. That's why we have to have things like fixtures and faker. We can't assert about constraints on the system and in terms of like all possible outputs. So constraints are a really, really important idea. We already work with a lot of special cases of constraints, like a type system is one kind of constraint. Validation rules are a type of constraint. Database relationships are a type of constraint. So these are all special cases of this higher level idea of constraints. And if we apply that more and throughout our systems, we can actually have more reliable code and write fewer tests. Fortunately, there's one language that has this idea of constraints built in. It's called Eiffel. No one uses it. That's all I got.